sort of go back a little bit to talk about sort of how we got to where we are today, and then take you into a bit of where we're going in the future, really where we're highlighting and moving into broadband as it's considered in the satellite and aviation space today. But one of the key elements, and it's most people probably don't appreciate or understand the type of presence that Iridium has in the aviation space, because we're not necessarily have the market penetration in some of the more traditional sort of solutions, but we are the market leader as far as the number of total equipped aircraft in the space today, with more than 50,000 subscribers specifically within aviation, and that's still growing at about a 10% clip per annum. So we're finding adoption continues to expand in markets where historically have been less penetration, primarily air transport, and safety services has been a key driver of that. So Peter had asked us to speak a little bit about some of the mandates that might be relevant to the audience and how it's driving satellite adoption. And he just referenced FAMS as being one of them. The other one I would highlight is some rule changes and regulatory aspects that are underway today that are alleviating the need for 2 HF radios on an aircraft that might go in oceanic or remote regions if you had an improved SATCOM solution. So one of the elements that we've been working diligently with AMSPs, primarily the FAA and those in the North Atlantic, is to be one of the market leaders in this adoption and enabling this replacement of the HF radio. And we've successfully completed some operational evaluations with those AMSPs. We've got several hundred aircraft that are using us on a routine basis for ATC communications now. And we're finding the OEMs and some of the aircraft operators are now actually getting MMEL relief to replace an HF radio with a SATCOM radio or SATCOM solution. One of the things that's the unique value of Iridium in this case is you're replacing something that's heavy and expensive to maintain with a SATCOM solution that is a bit unique from all the other SATCOM solutions you'll hear about. I think of David's presentation with the radios, and that's one of the areas that we're pretty much immune from. Being low Earth orbit, we're able to use antennas that are less than 1 inch tall and about the size of a hockey puck to maintain communication. So we're not going through calculations on ice buildup, drag, bird strike, or even structural integrity of the aircraft, because you're doing one small penetration, which gives you flexibility to put in a radio antenna just about anywhere nose to tail on an aircraft. So it makes us an excellent complement with other technologies that might be on the same aircraft. So really what I want to focus on with the remaining time is a new broadband service that we'll be introducing at the end of next year and really roll out with its functionality over the next couple of years to come, something we call Iridium Service. And there's a new element to a service portfolio that we're building out as part of our second generation of satellites that we'll be launching starting early next year. And which Iridium Service is the cornerstone of what that service portfolio will be. And the first element that we're focusing on introducing commercially is the broadband element of that. And we believe that it, hopefully I'll convey to you over the next couple of slides, that it's a cross-section of functionality, performance, and cost that really will set it apart from other types of solutions in this space. So a couple of things I wanted to really highlight on what are the attributes and why is this solution thought to be a bit different than the others. First and foremost is reliability. You've already heard Kurt speak about that there's an expectation that the connection is always there wherever you may fly. And that's one of the things that's core to our philosophy, core to our implementation, and also being approved and maintaining that approval for safety services. It's something that you need to execute on every day. So it's something that's inherently built into what we're doing as part of that safety portfolio that extends to all of the commercial capabilities that someone can use for non-safety communications as well. Also in the low latency category, because our satellites are roughly 450 miles above the Earth's surface versus 22,000, you have much more of a user experience that's akin to what you would have on a wireless network or a terrestrial network on the ground. So if you're looking to extend applications, they're going to look and behave much more like something if you're in a home office or in an airport versus latency versus something that's going to have 2 to 3 times more latency going that much further out into space and back. The safety certified, this has been one of the key elements leveraging our infrastructure today and our already approvals with AMSPs around the globe. So that day one, the new Iridium service terminals will be able to be safety certified or safety approved. So from day one, someone will have ACARS capability, safety voice capability, and they can fly fans routes without having to go through protracted evaluation with ANSPs. And we've already done ICAO and the FAA to ascribe to this philosophy. So we have their support in introducing these products with that capability. Everyone talks about global coverage. Well, we're the only one that truly covers the entire globe. Our low Earth orbit constellation, we actually have orbits that move sort of north to south and south to north around the poles. So we do provide polar coverage. And as we see more and more city pairs, especially with the extended range of these larger aircraft connecting Asia to North America or Northern Europe to Southeast Asia, more and more parties are flying in polar and near polar routes. And if you want to maintain that connectivity, whether it be for the VIP doing an email or a phone in the back, or your safety communications over the top, we're the only ones that are there from a satellite perspective. Your only alternative would be HF, and that's not going to help your executive keep connected. The small form factor, and I don't want to belabor this one too much, but our antenna solutions are really just totally different than everything else you hear up here. Extremely low profile, extremely small form factor, and really what that translates to is a lot lower price point as far as the antenna and the integration and installation capabilities. And lastly, one of the things we focus on is delivering value. So it's an affordable price point on the equipment, on the airtime, and just the total cost of ownership of what it means to install, operate, and maintain this on your aircraft. So when we look at service, there's really what we call 5 service classes, so denoted by maximum throughputs. And we sort of break them into 2 categories, one focused on sort of front of the aircraft and operational communications, and the other targeted more towards the back. Really here we looked at these top 2, the 100 and 200 service classes, and you can see the respective throughputs there. These solutions can leverage what we call the passive or the puck antenna today, so a low gain, omnidirectional, totally passive antenna. Many of you, if you have Iridium on your aircraft today, the antenna you have today can be used to support these types of solutions. The 350 category and the ones I'll go to on the next slide as far as cabinet solutions require what we call a high gain antenna, but again, that will be a phased array, low profile, very accommodative and antenna and affordable to install. And the types of performance that you can expect from those solutions really is unparalleled. So, try to explore what's a metric or kilobit per square inch or something like that. There really is nothing that's going to rival what Certus will deliver in the next 5 and 10 years. So we look more towards the cabin solutions. As Peter was highlighting earlier, some of the throughputs that need for streaming video of standard definition and high definition. We think that the solutions that we'll be delivering as far as the 700 and ultimately about the megabit and a half throughput range will find strong attraction and adoption in those smaller aircraft, because you're not talking about massive radomes with lots of weight and size, but also as that complementary solution to a K-band area that may fly out of coverage or may have regulatory challenges to operate in some countries, where the user could automatically switch over to a service solution, have that continuity of service, and really have no visibility that they've moved networks and they remain connected all the time. Because I don't think anyone in the room wants a call from the CEO, blasting that I was unconnected for an hour because we were flying in a particular location. I was on the ground and I couldn't get my email, which I had to get before we left. And this fills those sort of coverage gaps, as well as provides functionality for parallel safety communications in addition to these types of connections for the cabin. So just a quick timeline, and I'll try to go through this because I know Peter wants to stick to the schedule. So over-the-air testing for Certus with our partners will begin in the first quarter of next year. The second quarter of next year is when we start launching the satellites, and we have a very rigorous and schedule as far as 8 launches over a period of about 18 to 20 months, start to finish. In the third quarter of next year, we will have beta trials that will get underway with partners. Most likely these initial beta trials will not be in the aviation market. They'll be in some of the other vertical markets that we'll be supporting with Certus. But ultimately the functionality for the service and iron out any of the hiccups or bugs will be proven out during that period of time. And then we'll look to enter into commercial service sometime near the end of 2016, early 2017. And it's really the challenge there is getting to that critical mass of satellites. So the infrastructure that would go into the aircraft will have been developed and should be into certification testing at that point. The infrastructure in our gateway will already be installed and been tested for the better part of a year with customer and our own internal testing. So it's really, if we've got 66 satellites total that we've got to get into orbit, and roughly half of that is when we plan to introduce commercial service, because those early terminals will transition between the two constellations. So we get into later 2017, we're hoping to move forward and complete the MOPS for safety services installations of Certus terminals. And then ultimately, as we get towards the end of 2017, we would expect the very first Iridium Certus certified solutions to start to become available to the aviation market. So with that, hopefully I've yielded a little bit of time for Q&A, if there is any.
Just one question. Dan?
Yeah, so customers that have both, say, an Inmarsat and an Iridium solution, how do you handle the interference? Well, what's the recommended way to handle the interference?
Peter told me to be nice, so I won't give you the answer.
The easy answer is turn one off and use the other one.
Yeah.
I'm serious. I'm serious about that.
Well, we were both going to give the same answer, but
so they don't play nicely together. I think everyone who's tried to do that understands that and appreciates that. It is something we have deliberately incorporated into our engineering for Certus terminals to try to be more resilient in with an external interferer environment. That said, we can only do so much if there's emissions into our band, and hence filtering or turning off the other guy is optimal from our perspective. But there are some interesting technologies of partners, antenna solutions, and digital signal processing solutions that we're evaluating that we're hoping to make people's lives easier there. But there's no silver bullet that we're aware of that everything's fixed.